Now we are going to discuss one more property of the velocity time graph. In this we will try to show that area enclosed between velocity time graph and time axis gives the displacement of the object in the given time interval. What does it mean? Suppose that there is an object and it is moving with uniform velocity. Suppose here we have the velocity time graph of such an object. This is velocity and here we have time, and the velocity time graph is given like this. Okay, it's a straight line parallel to time axis. It means that it is moving with uniform velocity. Okay, and you have to show that area enclosed between VT graph, velocity time graph, and time axis gives the displacement of the particle in the given time interval. Suppose that this is the velocity v. Okay, this is point O, this is point A. Okay, and say this is point B, this is point C. Okay, now at this point of time the time is t1, at this point of time is t2. Okay, if this is t1, what does it mean? It means that from 0 to this the time is t1. So this is actually t1. When we say this is t2, it means that from here the time is t2, up to here the time is t2. Okay, now when we are saying time interval, so what this time interval means? This time interval means t2 minus t1. Okay, this time interval means t2 minus t1. So this BC is t2 minus t1. This is t1, t2 minus t1, and this is what the time interval is. BC is t2 minus t1. Okay, now at this time B, the velocity of the object is BC, say this is D. Okay, and it is velocity is V only, and at point C also the velocity is V only, say it is BC, D, or you can say it is D, and this is E. Okay, at both the points the velocity is V only. Okay, if velocity is V, what does it mean? That if it starts from here up to here, the velocity is this velocity is V. Okay, if this is V, then this also has to be V only. Okay, EB is also V. What you have to show is area enclosed between velocity time graph and time axis. So this is the velocity time graph, straight line, and this is the time axis. Area enclosed between velocity time graph and time axis in the given time interval. What is time interval? This is time interval, t2 minus t1. Gives the displacement. So where is the area? This is the time interval. This is the velocity time graph. So this is the area. This is the area, and this area gives the displacement. So what we have to show, that in this time interval the displacement covered by the object is given by this area. Okay, now how can you find this? So you can find it like this: area of VT graph, area between VT graph and time axis, VT graph and time axis. Okay, it is equals to what? Area of rectangle BCDE, area of rectangle BCDE. Now how can you find this area? Area is length into breadth. What is length? Say it is EB, and what is breadth? Say it is BC. EB into BC. Now what is EB? EB is nothing but velocity, that is V. So you can write it as V multiplied by BC, which is T2 minus T1. So you can write it as T2 minus T1. Okay. Now what is velocity? Velocity is the change in the position of the object with time. Okay. Or you can say displacement covered by the object in time interval. So you can write velocity as displacement divided by time, and time is what? T2 minus T1 is, multiplied by T2 minus T1, and that is cancelled. So what you are getting, area enclosed between velocity time graph and time axis is equal to displacement. It is equal to displacement, and this is what you had to show, that area enclosed between VT graph, velocity time graph and time axis gives the displacement of the particle in the given time interval. I hope it is clear to you. Thank you. To study the graphical representation of motion. In graphical representation, you must have studied the graphs in previous years. So in graphs, what we do, we take a particular variable on one axis, that is say horizontal axis, which is called x-axis, and we take another variable on vertical axis, which is the y-axis, and then we plot the graph between them. Okay, so we plot the different points and then we join them. This is what is called graph. Now we can represent the motion of an object graphically, and that is what is called graphical representation of the motion. So in this we are going to study different types of graphs. Like the first basic graph which we are going to discuss is the distance time graph. Distance time graph. This is the first graph which we have to discuss, distance time graph. Now in the distance time graph, what we do, we take distance on y-axis, distance covered by the object on y-axis, and we take the time taken by the object on x-axis. This is the time. Now what we do, we plot variation of distance and time, and this is called distance time graph. Okay. So there are various types of distance time graphs which are possible. Out of that, the first case which we are going to discuss is the uniform motion. So the first case in distance time graph which we are going to discuss is uniform motion. Now as you know that what is uniform motion, an object is said to be moving in uniform motion if it covers equal distances in equal intervals of time. Just now we discussed that what is uniform motion, if it covers equal distances in equal intervals of time. So suppose we start from point O and we are going on a straight line like this, and we cover the distance in such a manner that from O we start, we reaches to A, we reaches to point A, then we reach to point B, then we reach to point C, then we reach to point D, and let us start the motion from this point O, and this is say 0 second. This is 0 second. After 1 second, object is at point A. After 2 seconds, it is at B. After 3 seconds, it is at C, and after 4 seconds, it is at D. Okay. Now, as far as the distance covered by the object, so initially when we start from 0, this distance covered is 0 meter. Okay, because it is at that point only from where we are measuring the distance. Then after 1 second, its distance is say 10 meter. Okay. Then after 2 seconds, it is at 20 meter from O. Then after 3 seconds, it is 30 meter from O, and at last it is 40 meter from O. So these are actually the positions of the object at various time instants, and from point O or with respect to point O, these distances are given. Okay. So if you tabulate this data, okay, that what is the distance covered by the object in different time, if you tabulate this data, tabulate the data means to make a table of this. So if you make a table of this, so you will be getting a table like this. On one side there will be distance, and on other side there will be time. This is the distance time. Okay, it is like this. Now 0 second, at 0 second the distance is 0 meter. Then at 1 second, so time is in second, so I am not writing second now, and distance is in meter, I am not writing the meter again. So at 1 second it is 10 meter. It is 10 meter. After that at 2 second it is 20. 2 second it is 20. Then at 3 second it is 30. And at 4 second it is 40. So this is what the tabulation of the data which we have written here. Okay, and it is obvious that it covers equal distances in equal intervals of time, because in every 1 second you can see here distance covered is 10 meter. Here also 20 minus 10, that is distance covered is 10 meter. Here also in 1 second the distance covered is 10 meter. Here also in 1 second the distance covered is 10 meter. So you can see that in each second the distance covered by the object is 10 meter. Okay, and the tabulation of that data is there. इस तरह से हमने इसको tabulate किया है. अब अगर हम इसे ग्राफिकली रिप्रेजेंट करते हैं तो वो ग्राफिकल रिप्रेजेंटेशन कुछ इस तरह होगा, जो मैं अभी प्लॉट करूंगा यहाँ. तो वो टेबल है, उसी को हम यहाँ पर ग्राफिकली प्लॉट करेंगे. सो यू हैव द डिस्टेंस टाइम ग्राफ. ओके, हियर on x axis you have time, and on y axis you have distance. So this is point O. Okay, here you have time, so this is the time axis, and say this is 0, or say this is 0. Then time axis you need 0, 1, 2, 3, 4. So it is 1. Then after equal distances you have to take 2, 3 and 4 like this. Okay, so this is 2, this is 1, this is 2, this is 3 and this is 4. Okay, and as far as the distance travelled are concerned, 0, then this is 10, 20, 30 and 40. Okay, let us plot the points now. At 0 it is 0, so at 0, 0 on both the scales, that is the first point will be here. At 1 second it is 10 meter per second, so here 1 and here 1, here 10, this is 10, this is 20, this is 30, this is 40. Okay, so next point is this. Next is 2 and 20, so it is like this, and that is the next point. This is the next point. Then this and this makes it next point. And last 4 second it is 40, so this is what the next point. And though we have not taken the scales properly and marked them, but still you can see that if you join them they will fall on a straight line. These points will fall on a straight line. So if the distance time graph is a straight line inclined to time axis, what we call it, inclined to time axis. If distance time graph is a straight line inclined का मतलब होता है कि इस एंगल पर है, कुछ एंगल पर है ये, inclined to time axis, then it represents the non-uniform motion. Inclined to time axis, then it is represent the uniform motion, and because it is a straight line, that's why it represents the uniform motion. I hope it is clear to you. Thank you.